start manada. So here we are seeing all the cells which are present in the different layers. This is the basket cell and the stellate cells, the dendrites of which will arborize in the molecular layer, the axons of both of them which will go and synapse with the Purkinje cell. And the other cells, other fibers what are seen in the molecular layer are these parallel fibers. Yes, you can see them. The axon of granular cell is coming here and dividing perpendicularly and form what is called as parallel fibers which come and synapse with the dendrites of Purkinje cells. This red color what you are seeing here is the climbing fibers which is coming from the inferior olivary nucleus of the medulla oblongata. Okay. Next, what you are seeing here is these are the other types of fibers which are coming from different parts, spinal cord, brain stem, everywhere to the granular cell, and this is form what is called as the mossy fibers. Now, these mossy fibers are going end into expanded portions like this which is called as the rosette, which will synapse with the dendrites of the granular cell and also the axons of the Golgi cell. Now, when they are forming this, so in turn the mossy fibers will excite the granular cell. This granular cell will go and inhibit the Purkinje cell. So, all the cells of your cerebellum are inhibitory in nature except for your granular cell which is excitatory in nature. So, this form of relay where the mossy fiber is going to stimulate your granular cell which in turn will stimulate your Golgi cell, and this Golgi cell in return will inhibit your granular cell. This type is called as feedback inhibition. As stimulation of mossy fiber of the granular cell through the parallel fibers stimulating your Purkinje cell, giving out the inhibitory output to the cerebellar nuclei. This type is called as the feed forward inhibition. So, this is carrying forward the impulses to the deep cerebellar nuclei, whereas this feedback inhibition helps in regulating the control of your granular cells. So, this is the picture of your cerebellar glomerulus. So, they can ask you what is the components of cerebellar glomerulus. It is formed by the rosette which in turn is formed by the mossy fiber which synapses with the axons of granular cell, the dendrites of granular cell and axons of your Golgi cell. So, the final input which is coming into the cerebellum is through two types of fibers, climbing fibers coming from the medulla oblongata and mossy fibers coming from different parts of the spinal cord, brainstem and the cerebral cortex. The final output is from the Purkinje cell which is inhibitory in nature. So, climbing fibers, they originate from a single region of the medulla, that is your inferior olivary nucleus. So, what they are doing is one single climbing fiber is making multiple synapses on the Purkinje cell. So, it is going to excite lot of Purkinje cells at a time. This helps in conditioning of the Purkinje cells, which is important for cerebellar motor learning. For example, when you are learning how to walk or when you are learning how to type, so those corrections which have to be made, you come across some obstacle. So, you are going to go across the obstacle. So, that learning is done through your cerebellar motor learning. That sharpening is done with the help of climbing fibers. Whereas mossy fibers, they are originating from many centers which includes the brainstem and spinal cord, and they multiple synapses on the Purkinje fibers via interneurons. So, these synapses will come into the glomeruli and from there it will come and excite multiple Purkinje cells. These are a summary of all the afferent fibers which are going to come into the cerebellum. We would have studied this in detail, what is the function of each tract which is bringing into the cerebellum. So, you have wide variety of afferent tracts which are coming into the cerebellum. The output pathway is all this will go and relay into the deep nuclei, and from the deep nuclei through various cerebellar peduncles, the output is going from the cerebellum. But from a functional point of view, we can classify the output from the cerebellum into three different parts. From the vestibulocerebellum, we have already seen The fibers originate in the median zone or the vermis. From there, they pass into the vestigial nucleus, and from there to the reticular formation and vestibular nuclei. And through this, they are going to control equilibrium, posture, and also movements in the axial, neck, shoulders, and hip muscles. From the spinal cerebellum, it is going to the nucleus interpositus, so paramedial region of the cerebellum. From there, they go into the thalamus and the motor areas of the cerebral cortex. From there, they are going into the basal ganglion and reticular formation, and they help in coordination of movements in the peripheral parts of the limbs. Then from the cerebrocerebellum, it is the lateral zone of the cerebral hemisphere. They pass to the dentate nucleus, to the thalamus, and finally they help in planning and coordination of sequential movements. So all the three cerebellum coordinate together to form the functions of the cerebellum, which is mainly two main things. Regulation of tone, posture, and equilibrium, which is required for your daily activity. Your standing, sitting, movement, everything is dependent on your cerebellum. This is done by receiving impulses from the median and paramedian part of the cerebellum, representing the vestibulo and spinal cerebellum. The more learned activity what you do, like how you are watching this online streaming right now, that coordinated activity by various actions we will be seeing now, this is done mainly by your corticocerebellum. It is a higher level of motor function. So how is it going to coordinate this repeated activity? By a wide variety: servo mechanism, damping action, ballistic movements coordination, planning and timing of these sequential movements, and a comparator function. What are these? Now these patterns are learned by trial and error over many repetitions. So whenever you are learning something, so what we all departments keep stressing on you, if you read once you will never get it. So repeated reading, repeated revisions and writing is what will help you to establish all these learned activities. So this fine balancing adjustments you make while standing and walking, that is having learned over a long period of time. Like when you were toddlers, you learned how to stand. Standing was most important for you then. Now standing for a long time, learning to shift your weight support during that time, all that is a continuous learning process which happens. That fine tuning happens every day, but the process of standing and walking was learned much earlier. And the ability to fine tune a complex pattern of movement comes with practice until the movements become fluid and automatic. So like last class only I told you, a typist in the beginning will see the keys, where the key is, where A is, where B is, and then will type. But after some point of time, her eyes is just on the monitor. She can blindly, literally blindly type all the keys without making any mistakes. So that is done by repeated activity. So how are these done? The damping action means it prevents exaggerated muscular activity. So it is smooth, like a lady makes voluntary activities smooth and accurate. Now these movements are initiated in the motor areas of the cortex. From there it gets projected on towards the cerebellum, from where it sends feedback to the periphery. So both feedback is taken from the center and the periphery, and the motor activity is fine tuned. So if there is any mismatch between the center and the periphery, those extra impulses gets cut off at the cerebellar level, helping in making the action smooth. Coordination of ballistic movement. So whatever movements are taking, rapid alternative movements will be taking at different parts of the body when you are doing a skilled work. Like for example, cycling or dancing, you are repeating the same steps again and again. Now this helps. The pre-planning is done here in the corticocerebellum. When should that activity be done? How should it be done? What is the extent to which should be done? All that is planned with the help of your corticocerebellum. Again here, planning of these sequential movements. So both the cortical level and at the spinal level, this information is relayed and processed in the cerebellum to do a smooth activity. Comparator function, it is responsible for integration and coordination of various muscular activities. So it is like a moderator present. So he asks questions from the audience and then relays it to the whoever is there. They give back the question. So like that, it receives messages both from the cortex and the muscles. The cortex is telling, no, something is wrong in the periphery. You ask them to correct. The periphery is saying, we are correct. Something is wrong at the center. So like that, those processing or those moderator function is done at the level of your cerebellum. Then any disturbance which are occurring in the performance of the skilled work, this also is being corrected at the level of the cerebellum. So once the skilled works are learnt, the sequential movements are done without any interference. Now in case there was any disturbance also, whatever memory has been learnt, that is called upon, and this will influence the cortex in order to correct the disturbance which is occurring. So this is all the functions of your cerebellum. And new things are also, so extra motor predictive functions. Now everything can't be learned, every day you come across something new. So this also is a continuous process which is done by the cerebellum. For example, you see here, auditory and visual phenomena has to be predicted by the brain, and both of these require cerebellar participation. So you are receiving auditory impulse, you are receiving visual impulse at the same time, and that will help in maintaining your visual balance and equilibrium of the body. So here they have given you an example how a person can predict the changing visual scene or how rapidly he is going to approach an object. So as soon as you see a dog or something outside, you can see whether it is running at you, at what speed it can come, or how fast you are supposed to run in order to escape from the dog. So this is a continuous learning process. This cannot be learnt as such. So this also is done by your cerebellum. So for the blood supply is done by 3 arteries. So as you all know, the 2 vertebral arteries unite to form the basilar artery at the lower border of pons. From here you have the superior cerebellar artery supplying the part of superior surface. Here you have anterior inferior cerebellar artery supplying a part of your inferior surface, and posterior inferior cerebellar artery, a branch of your vertebral artery, supplying the rest of your inferior surface. Okay. Now coming to the lesions of your cerebellum. Now these usually occur due to either trauma or vascular occlusion of any of the blood vessels we have talked about, or tumor. When you studied the pons, you have studied the cerebellopontine tumor angle. Now this affects mainly the motor system. Now this is evident with all the functions we have seen of the cerebellum, and this is very important for you know to know. Unlike that of the cerebral lesions, which are usually contralateral, all lesions which occur with the cerebellum are ipsilateral. So if the right cerebellar hemisphere is damaged, all the signs and symptoms will occur on the right side. So what are these set of syndromes? And this will be easy for you to classify based on the function when you know. So you know archicerebellum is concerned with the vestibular part. So if there is any disturbance of equilibrium, what is the sign you see? Is he finds it difficult to walk or difficult to balance, because of which he'll walk with a wide base and he'll always move from side to side. And if you ask the person to walk along a straight line, normally you and I will be able to do it. Even if I ask you to close your eyes and do it, you will still be able to walk in a straight line. But unlike that, in cerebellar lesion ataxia, because the person loses balance, he will not be able to walk with a straight line even with his eyes open. But if you make his eyes closed completely, he will lose balance, and this is called as a drunken gait or cerebellar ataxia. So you can see the person here, wide base, and he sways from side to side and tends to fall. Neocerebellar lesions are represented by a classic triad of hypotonia, where the tone of the muscles will be lost. So how do you test for the tone of the muscles? You would have studied in physiology different muscle reflexes. Pendular jerk. So knee jerk, what you do will be pendular. It will keep on moving and does not stop. Intentional tremors. Involuntary activity, involuntary motor activity is called as tremors, and intention tremors means whenever you start doing a motor activity. Now suppose at rest I do not have any tremor, but when I start to point my point this stick towards here, suddenly my hand starts shaking, so that forms an intention tremor. And the classical sign in cerebellum is the tremor stops at rest. And there's various disturbances in muscular coordination. The entire entity is called as asynergia, which has different components. Ataxia has already been seen, incoordination of trunk, pectoral and pelvic girdle resulting in altered gait. Dysmetria, inability to measure distance or overshooting. So somebody gives you a juice, when you reach out for them, you are able to judge at what distance the glass is from you. You are able to correctly hold the glass and bring it back to your mouth and have the juice. But in cerebellar ataxia, what happens? Your inability to judge the distance, and hence you will either overshoot or undershoot from the desired substance, desired object. Now decomposition of movements also. Now since you are not sure at what distance this is occurring, you will have jerky movement, and this will look like puppet-like or robotic movements. And you have a condition called as dysdiadochokinesis. That means the inability to perform rapid alternative movements like supination and pronation. He will not be able to do so. So you can see here overshooting. This is the finger of the examiner. He is asking him to touch the tip of his finger. So as the person is approaching here, he is not able to point at this finger. Either he will overshoot it or undershoot it. So he is not able to judge the distance. So rapid movements not able to do so, dysdiadochokinesis. Again here also dysmetria, not able to judge. Finger tremors occurring. This is your intentional tremors. Walking will be unsteady. We have another phenomenon here called as the rebound phenomenon. Usually the agonist and antagonist muscles are acting in coordination so that the muscular movement is smooth. Here what happens? As you can see here, the examiner is trying to extend the hand or extend the forearm of the person forcefully. Now as he removes that, the patient is not able to hold back his hand, instead he hits his face. So that coordination is also lost, and that is called as rebound phenomenon. You have dysarthria, where the muscular coordination of the speech muscle or the muscles of the tongue is lost, resulting in slurred speech. Muscular incoordination of the extraocular muscles will result in oscillation of the eyeball, which is called as nystagmus. A classical sign of nystagmus, dysarthria and intentional tremors are what is called as Charcot's triad. So intentional tremor is the key factor here. So to summarize here, we have seen what is the cerebellum, where is it situated, what are the various subdivisions, what are the various lobes of the cerebellum, what is the functional and morphological one, and also we have seen the applied anatomy. So to give you a clinical scenario here, you can see those highlighted words will tell you what the symptoms are. So you can see here clumsiness, right hand, SIMS started 3 months ago, getting worse day by day. Notice tremors, but read the sentence. Notice tremors when he wrote. So at the time of activity, intentional, which disappeared as he stopped. So resting tremors is absent. This is very, very important to differentiate from other kinds of tremors. You also told he tends to sway, so he is losing balance. So on examination, you are seeing hypotonia, then he is not able to walk on a straight line, and this is touching the tip of the finger. So this is overshooting, and dysdiadochokinesis and nystagmus is also seen. So these are the classical signs and symptoms you see with cerebellar ataxia. So cerebellum is usually a main question for you, and it will be asked under the following headings: location, subdivisions and their function. You have to write all three subdivisions: morphological, anatomical and functional. So cells of cerebellum, more of histology, you have to write about the excitatory, inhibitory effects, what is the input and output, and applied anatomy with explanation of each type. So main thing is ataxia, hypotonia and intentional tremors, what you have to write for cerebellum. Now it is a one for all the students. If you have any doubts regarding the current topic of now, please put that in the live chat and we shall be able to clear your doubts now. Regarding today's current topic cerebellum, if you have any doubts, kindly mention that in the chat. No other queries will be entertained. We shall give you 5 minutes time. If you have any doubts, kindly post that on the comment section and it will be addressed accordingly. Huh? Okay, somebody has asked for repetition of the cells of cerebellum. You have already done that histology in detail. So the cells of cerebellum are divided into 3 layers: the outer molecular, inner middle Purkinje and inner cell here, that is the granular layer. You have two types of cells in the molecular layer, that is basket cell and stellate cell. Purkinje cells which are seen in the Purkinje layer, a single layer, and in the granular cell you are seeing only two types of cells, that is your granular cell and Golgi cell. Golgi cell is the largest one. All the cells here are inhibitory in nature except for your granular cell. So the dendrites of these two cells are seen in molecular layer. Axon you are seeing are synapsing with the Purkinje cell. Dendrites of Purkinje cell will synapse with axons of granular cell which is called as parallel fibers and this climbing fibers. These axons will form what is called as the final output which is coming to the deep cerebellar nuclei. Golgi cell which is going to regulate the function of your granular cell. Granular cell which is receiving all the input from the different parts of the body as mossy fiber. It is only excitatory neuron. It is going to stimulate many Purkinje cells here. So these forms the main cells of your cerebellum. In the molecular layer, Purkinje cell layer. These are your flash shaped cells and your granular cells. Okay. Indena. Okay. Since there are no other doubts, we'll be ending this session. Thank you.